Hello everyone, welcome to week 6 live session for Introduction to Haskell Programming NPTEL course. I am Sai Venkatakrishnan, a PhD scholar from the Department of Computer Science and Engineering at IIT Madras. So the agenda of this live session is if you have any queries in the week lectures, or if you um, have any other doubts in the assignment, you can ask either in the chat box, or you can unmute yourself and uh, ask. So the agenda of this live session today, we'll be discussing week 5 assignment questions, the programming assignment questions. Okay, so let's start the session. So similar to week 4 assignment, week 5 was also a programming assignment, and it's basically you should write the functions. You should code the functions and submit it. And provided if all the test cases pass, then you will be awarded marks based on it, right? So let's start with the first question. The first question wants us to define a function called subseq, which is subsequence, which takes two parameters. One is the string parameter, and the other is also a string, and it should return a bool as the output. So this is the output, and the logic of this function should be such that the first argument is a subsequence of the second. That is, a subsequence is obtained by deleting some letters in a string and retaining the other characters in the same order as in the original string. So they have given some test cases. So for example, given this two strings AB and ABC, we should check whether AB is a subsequence in this larger string ABC. It is, right, so the answer is true. Whereas if we come to the second test case, whether AB is a subsequence in the string ACB, that also returns true, because if we remove C, AB is still present, so it's true. Whereas in the third case, AB is whether it's part of BCA, it's not, because BA is part of BCA, but the order is different. It's in the opposite way, so that's not a proper subsequence occurrence. So it should return as false, right? And and the fourth and fifth cases are sort of trivial. If we are checking for whether the empty string is a subsequence of any string, it should return true always. And if both the strings are equal, then it should be true always. So these are all sort of the trivial cases. So your function should have this logic. It should compare both these strings. It should check whether the first string is a subsequence of the second string, provided the order is also maintained, right? So how did you all code this function? What logic did you use? Before I discuss the solution, right? I want to hear from you.
Hello, sir. Am I audible?
Yes, you are audible.
Yeah. So, so what I did was, subsequence of an empty string. Subsequence empty string. Uh, if the empty string is the first argument, then any string that you pass as the second argument, it always returns true.
Okay.
And uh, suppose the empty string has only one character.
Okay.
Sorry, the first argument, the subsequence string, the first argument, if it contains only one character, then uh, we can maybe use the lm function. So subsequence of, so the first argument is a single character
Hmm.
as a string. So the string containing one character, and if any string is passed as the second argument, then we can use the lm function, which checks whether one the first is contained in the second. So lm of that character, whether it is contained in the second string. So that is that is like the base condition. So these two are the base conditions. First is checking for the empty string, and then checking for a single character subsequence.
Right.
And then the general case, or the inductive case. So if you pass, say, subsequence ss is the first argument and s is the second argument, then uh, the general case would be you call again subsequence with the first argument as the
Hmm.
tail of ss, and then the second argument will be uh, so first so for so the second argument, so the logic that I used was, first we do a uh, drop while
Okay.
on the main string s, and check for whether the head of the first, I mean the essentially the first character in the subsequence, the head of ss.
Right.
So we parse through the string uh, and keep dropping elements as long as they are not equal to the first uh, that character. So drop while of the function would be not equal to head of ss, and then we pass the string,
Right.
and then uh, whatever. Uh, so what we'll essentially get is, now we have checked for the first character.
Hmm.
I mean, we go through the string until we find the first character, and then we can just do a tail. So what we'll get is, now the string that comes out of drop while would be, the first character will have that uh, character which matches with the subsequence character, the
Right.
first subsequence character. And now if we do a tail of that, we are essentially dropping that now, because we have found that first character. Now essentially what we want to do is now recursively look for the next characters in the subsequence with the remainder of that string list.
Right.
Yeah. So
Okay. Good. Right. That's correct, Yagarajan. Good. And Sagar, your answer also is correct. Okay. So basically, the logic is if you have two strings. So as both of you have mentioned, if you have say two strings, you should first check for an occurrence of whether this character is present in this string, and if it's present, till then you should be iterating through the string, and once you hit a index character where this a character is present in the second string, you check for the next string starting from the next position in this, right? And this will keep on repeating until you empty this whole string out, the first string. That's the logic, right? So let's look at the code. So I actually didn't sort of uh, I used indexes. So what Sagar had mentioned in the answer looks much cleaner, and also is sort of more FP oriented, right? So this code, whatever I've written, is sort of it is FP oriented, but sort of like having coming from a C background. In that perspective, I wrote the code, right? So basically, whatever Sagar had written, it's same as mine. But instead, what I don't do these pattern matches on. So basically, I didn't do this pattern match XXS or YYS for the both the strings. Instead, I am defining an auxiliary function, and I am passing two integers, and these basically denote the current index pointing into both the strings, right? So basically, these this condition over here, this if clause, right? The same as what Sagar has mentioned in the chat box. which is the otherwise and the x equal to y, right? These two conditions are the one which is being mentioned. So instead of passing the tail of the string, I'm passing the whole string, but I'm changing the updating the indexes which are pointing into the string. So that's the main logic which I have done. And as you notice, right, these pattern matching and all these things make code much simpler and more easier to understand. So here I'm not using any pattern matches or anything. So the code looks sort of like complicated, right? But if you notice Sagar's code, it's sort of like cleaner as well as more easier to understand. So that's the advantage if we use these pattern matching constructs and all these things which Haskell provides. So in that case, let's move on to the um, second question. So define a function subword where it checks, so it takes two arguments, string and string, and it checks whether the first argument is a subword of the second, and it's by deleting some number of letters at the left end and right end in a string and retaining the other characters, right? So for example, they have given some test cases. So subword of AB in and ABC, it's true because AB is present in ABC, whereas subword of AB and ACB is false because they are not asking for subsequence, rather they are asking for subword. So in a subword, all the there shouldn't be any extra characters in between. So either on the left or right side of the word you can delete the characters, but not in between. So that's what the subword is all about. So subword of CA and BCA is true, and subword of, if it's equal, it's true. That's a trivial case, and any empty string is subword in a larger string. So these two are trivial cases, and these are the main logic you should take care of, right? So can anyone of you mention how you solve this question? Uh, anyone, Tyagarajan or Sagar, anyone, can you, if you have solved this question, can you share your code snippet or can you explain how you solved this?
Yes, sir. Just give me a moment. Actually, I'm on a mobile phone device and I'm finding
Oh,
it
okay, okay.
difficult to copy
Okay,
paste.
no worries.
So that's why. Also to Sagar. So he asked me whether if he can share. So I'm actually trying to figure out if I'm able to copy paste that code from my submission, but I'm finding it difficult on a mobile phone device.
Right.
That's
Sagar, have you solved this question? Second question. Can you share your code snippet or can you explain? Okay, check prefix string. Check. Okay, blue comes SQL prefix. So what does check prefix and check suffix do? Okay, you check from the left side as well as the right side. Right. So does this pass all test cases? This implementation saga. Okay, so for this question it passed. Okay. So first you will check A and A, B, C, and then both are okay. So they are not. So, so will this test case pass, Sagar? So will this pass in your implementation? Can just you have? Are you sitting in front of your computer? Is it working, Saga? What about this string? The second case, did you check? No, no. So this one, what did it return? This one, what did it return? This one, true, is it? Okay. This one, right. So this one should be true, right? Because AB is a subword, right? So, so the thing is, I guess in your function, right? So the logic should be so it's the same as actually subsequence logic, only the same logic, but I guess the difference is if you are checking for this, right, ACB, AB, CB. So basically what I am doing is I am checking for, so in subsequence what I did is I check for the first character. If it's there means it's a tick, and I go to the next character, and then I check over here, I check over here B. If it's there, I'm ticking it. So this is for subsequence, right? But for subword, if it's failing somewhere, right, I should start from the first, the checking. So basically, if A is there, it's a tick. Okay. Now B, if it's not present next to A, then so basically that subword is broken, right? So there's some other character which shouldn't be there in between the subword. So then basically the search should continue again from A. So all these things should be erased, and the search should again continue from the first string's starting index, but in the second string it should continue from the last unchecked thing, the from this character. So here it's not present, here it is there, so it will be a tick. Now it will check, and here it is there. So this reached the end of the first string, and so it returns a true. So the first one, why it returned a true for in your case is you're doing this check suffix, right? So in the check prefix it will be a false, whereas in the check suffix, right, since B and A come in the first place itself, it returns true. But whereas in the second case, the check prefix will return a false, um, because check prefix will return a false because here you're checking B equal to C, and you're just stopping with that, I guess. And here also in the check suffix case also, this character is between, the C character comes in between, right? So I guess that's the problem. But anyways, your um, the public test cases, I guess, pass, so that's not an issue, right? So this is my logic actually for subword. So subword of auxiliary. So I am so same way, right? So same as what I did for the subsequence, like passing two indexes to be checked in string 1 and string 2. So the same way I've been doing for subword also. It's the same logic, but if you notice over here, the only difference is if both if the characters at both the indexes are equal, I increment both the indexes by 1. Otherwise, I start from the starting of the first string. So I place the index 1 as 0 and index 2 I just increment. So compare this condition over here, right? This condition over here with the subsequence condition, you will notice the difference. So here I just start with, I just retain index 1 and just increment index 2 plus 1, but over here if it's not equal I term it as 0 and I do index 2 plus 1. So that's the only difference between subsequence and subword, right? So right, we need that exact word. So actually the reason why I included this type of indices and not going that pattern matching clause in the first question was actually I coded subword first, right? So subword I needed to have a context that the state I should be maintaining throughout the series of recursive function calls, right? Like whether the previous what my previous string was, I should be maintaining it, the exact string, so that if it not matches, then I should start the matching from first again. So for that, I sort of wanted the indexes to be passed along with the function. So the same logic, I just applied it to subsequence also. But in my personal opinion is like I guess there would be a sort of more efficient way and more clean uh, easier way to code this subword function, I guess, in a way which is, you know, like how you coded the subsequence, right, Sagar? So in the same way I guess subword also can be sort of coded in a clean way, in an easier way. So I didn't have much time to work on this, but this like sort of like a nice solution. But that's like a much cleaner way, I guess. So if any one of you like come up with a better clean solution, you can share it in the next session or you can post it in the discussion forum. That would be like an interesting take-home exercise. Right? So
So maybe I can maybe just describe what logic I applied.
yeah, yeah, sure.
Yeah. So what I did was, so first uh, so I mean I have written this code in one single line, but I'm just kind of breaking it down and uh, letting you know. So first I created a list containing set of indices
Okay.
uh, that match. I mean, the set of indices in the string where the first character of the subword matches with the first character, or I mean, the first wherever the first character of the subword appears in that string.
Right.
So that can be done with a list comprehension where you uh, the set of all i's where uh, I goes from uh, the length of the I is goes from 0 to length of the string minus 1, and you check whether the ith position matches the ith first position of the subword.
Okay.
So that creates a list of indices. Then that list of indices can be passed. So I uh, wrote a map function where uh, the input list is that set of indices, and the function which is applied to that list is, so it takes every index and then essentially extracts subwords at those locations of the same length as the subword that we are trying to match.
Right.
So say if it is 0, so if the indices are 0, 4, 7 and the subword length is 3, so then at the 0th position, we extract the subword of length 3 and then compare it with the given subword.
Right, so
So that will,
basically you get there. So this is 0 index, this is 0 1 2 3, and right, so this is one index and this is the second index. So this will
yes,
be your list, and now your map function. So this is the first element. So starting from 0, you will get two characters, so A
yes,
and C, and you just check for equality
yes.
with AB. So if it's not, then you return false, and now you check from 3 and 4. If it's true, then you return true. Right?
Correct.
Right. So list dot map, it will basically generate list of false and true. So if anything is a true, then it will be
Yeah, then that list of bools, I do a folder uh,
or
or
right, right,
folder or,
right,
and
right.
that gives me.
Nice, nice. Okay. Yeah. Nice, Tyagarajan. So yeah, this will work for sure. So, yeah. When, if possible, you can share your code on the discussion forum, or you can share it next week also.
Yeah, sure. Yeah, no problem.
Yeah, okay. Nice. Good, Sagar. Good, Tyagarajan. So, in that case, let's move on to the third question. Right. So, third question is sort of there are multiple sub questions. So we'll go one by one. So basically, they are asking us to define a two-dimensional matrix represented as a list of rows, and each row itself being a list of elements. So it is sort of a nested list. So one, two, three, 1 2 3 is nothing but the matrix 1 2 3 1 2 3, right? So this is row 1 and this is row 2. So this is what your matrix would be represented as a list of lists in Haskell, right? So given this representation, we should be uh, doing the following questions, right? So define a function is matrix which takes a nested list, right? And it takes and returns a boolean that checks if a list of lists is a valid matrix or no, right? So non-zero number of rows and each of the same non-zero length. So basically what they want to know is number of rows not equal to 0, and number of columns should be same. So number of columns nothing but elements in list element, right? So the list element is sort of this nested list. So within this, how many elements are there, right? And number of elements within each list in that nested list should be the same. Then only denotes equal rows. So if it's say like 1 2 3 and then 1, right? So this is also a nested list, but it's not a valid matrix because now what are these numbers, right? So this is not a matrix, whereas this is a matrix, right? So they have given test cases. So if it's like an empty list or something, it should return false, and this case it should return a true. So this is like just a single row, whereas this contains 3 rows and 2 columns. So 2 columns because each row has 2 elements, right? So so logic that you used, anyone can you share?
Yeah, hello, sir. Yeah, so I essentially again used a combination of folder and map,
Okay.
where so first we can do a map function with uh, so the list would essentially be uh, uh, I mean it goes from 0 to uh, the number of rows minus 2, or I mean the length of that
Right.
list minus 2.
Right.
And so that's the input list, and the function is for each uh, element in that list, essentially, I mean, what I'm doing is I'm comparing whether the length of the first element is equal to the length of the second element,
Right.
or the length of the ith uh, length of the ith row is equal to the length of the I plus 1th row.
Right.
And if we apply a map that essentially compares the first row with the second row with the third row with the fourth row, and so on.
Okay.
Uh, so uh,
So not map, right? Fold, right?
uh,
Map
yeah,
will
maybe no, maybe I think this logic could have been applied with a fold as well, but I have used the map function.
no. You got the length of the list for using map, and then checking the first with the second, second with the third. That is fold.
No. So this is within the map. The anonymous function passed to the map. What it does is, so the list contains, say, if there are 5 rows, the list contains 0, 1, 2, 3.
Okay.
So those are the index row indices.
Right.
Uh, and then the function, what it does is it compares the length of the first row,
Okay.
or whether it is equal to the length of the second row, or ith row compared with I plus 1th row. So that happens for every subsequent. So the 0th row length would be compared with the first row length. Then the first row length would be compared with the second row length. And this would eventually the map function would return a list of bools.
Right.
So if these are all true, then we can do a folder with an AND operator.
Right.
And then if all are true, in that I mean the map function, if it returns a list of all trues, if we do a folder with an AND operator with the accumulator as the true
Hmm.
uh, value, so only if we do an AND, then that would eventually return a true.
Right.
So this case is does not handle the empty list case. That is, I mean, I've written a special different case for that. So
Right.
this is only if all the elements, all the rows are non-empty. So this
Right.
case, what I mentioned,
Right.
is for if all the rows are non-empty, and if so there is a case for when so if one of the uh, rows is empty, then so there is a case for that where I do a map function
Right.
and pass the length function as the argument.
Hmm.
So that a map function with a length function as the argument passed to this list of lists would return essentially uh, the length of the, or the number of columns, or the number of elements in each row. And if there is any zero in that returned list, then we say that it is not a valid.
Okay. Cool.
Yeah, it's a little bit maybe
Right. Yeah.
complicated.
Okay. So I guess my solution is also sort of similar to what you have proposed, right? So first I define this auxiliary function length lists. So length list is nothing but it just generates the length of each nested element within that list, right? In that nested list, each row, how many elements are there? I just find it out using the map function. So I get this list, right? So if it's
Yeah.
like, uh, so you basically get an array, a list containing the number of elements in each row. And now what I do is, instead of using fold, what I do is I just define this is matrix function, and is matrix. So I guess I'm using, yeah, fold is this, right? So this thing. So This matrix I'm just checking for if it's an empty string. It's a false. If it contains, okay. So I'm not sure whether this will pass the second test case, which is, yeah, it will pass. Okay, okay, sorry. Okay, so I'm doing is I'm just now getting a matrix M1. I'm generating the length of each row elements. I'm storing it in this list L1, and I'm getting A equal to head of L1, and so basically what I'm doing is I'm getting the first element, and I am equating this element to all the other elements within the list. So whether 2 equal to 3 equal to 3 or 2 equal to 2. So I'm just checking. So by that I will generate a list of boolean, a list of bool values similar to what you mentioned, right? Tyagarajan. List of bool values. And now if anything is false, I basically do an AND of all the values. It will return a false. If everything is true, that is if it's equal to the first element, then everything has the same number of elements, right? So it will return a true. The special case is if it's a zero, if the first element is zero, it's a false.
Sir, could you explain the last uh,
Right. So
else condition?
this
And
is
also that operator dollar. I mean, so I've seen it, but I don't exactly understand how that
right.
works.
So yeah, actually, to be frank, right, even sort of like I don't know this dollar, right? So I I sort of thought of using folder only. I got this dollar sign like when I was going through some code bases, they had used this dollar sign in place of folder
Okay.
to mention this um, this sort of like handing all the elements in the list of bools. So shall I like look up and tell you what the dollar sign actually does? Like,
Yeah, it's okay.
right.
Yeah, please.
Like
So,
yeah, so instead of folder, like I thought of like looking up so this part alone, like I sort of like looked up Stack Overflow, like other code bases, right? But
okay.
I didn't have time to fully look at up what is dollar sign, like what logic is being used underneath. So this syntactic sugar, I guess, I'm not sure, but I'll just look up and tell you by today or by tomorrow.
So the and so is there also an and function instead of the ampersand? So I have not used it, so I'm just asking.
Yeah, yeah, and the function it's done.
Okay, okay.
Even
It's same as the ampersand. Uh,
yeah, yeah, it's okay. Well, it's same as the ampersand. Let me check now. It's here. Right, right. So um, let me share my screen. Uh, yeah, is my screen visible?
yes, yes.
So over here, if you notice, this ampersand over here, right? This is, if you notice the type, it takes two bool and it returns a bool.
Yeah. Hmm.
But if you notice this, right, and function which I had used, it takes foldable t. So this foldable is sort of this type class, right? So whether you have that ORD, all the type class and those things, right, which we
Yeah.
had seen in the previous week lectures, I guess, this week or previous week. So whether so all the integers in floating point, those things would be under the num class or something, num type class. Um, ORD type class means you can use the greater than or lesser than sign on those types, right? If it's like EQ and T, something like that, equality class means you can use the equal to sign on those types, right? So similarly, like foldable is a type class, and foldable denotes like your passing something which is like you're passing a list or some structure, data structure, which can be folded using this fold_r or fold_l function. So if you look at the type of fold_r also, so if you notice this is like foldable of T, right? So if you notice this part over here, TA, right, over here. So this part TA is nothing but actually the list whatever you are passing, right, which has to be folded, list of bool or something, that is actually passed, that type is actually T bool, right? And the T bool denotes like this T is actually foldable of T. So your list is actually not this, okay. So basically this foldable denotes a type class, and your list and everything would come under this type class foldable. So that's what it denotes, right? So okay, I guess I got the logic now for this and dollar. Nice question, Tyagarajan. So there's a difference between this ampersand and function. Ampersand is just a binary operator. This and function is sort of something which is to be done on a foldable data structure, right? And and if you notice over here, this AND takes one argument and returns a result, and this argument is nothing but this foldable list, right? This foldable list of some foldable structure, but it should contain boolean elements, and it will return a final boolean element adding all these boolean values. So basically what we are doing is generating a generating a boolean list, right? Over here we are generating a list of bools, and this will be of type uh, bool, but this list of bools actually comes under the type class foldable. Like lists are foldable, so it comes with this type class. So when I apply and to this, it will be it will work. So let me check whether this works. Right, so if you notice and of false, true and true, it returns false, whereas and of all trues, it returns a true. And if you notice this dollar sign, so this dollar sign is basically this dollar sign is basically an infix operator, right? So that's why I'm as a function, if you want to see the type of this dollar operator, you should enclose it within parentheses. So similar to how we had seen in the first class, right? So same way. So this dollar is sort of takes one function, and right. So this one you understood, right? And what's the difference between and ampersand ampersand?
Yeah, yes, sir.
Right. So a good question, Tyagarajan. Like even I found out now only, like and is using the foldable thing. This dollar sign is something similar to the dot sign, I guess. Not exactly similar, but something to do with this function composition like that. Like you generate, so instead of having this extra um, parenthesis and all that thing, right? So let us just, right. I got a nice link for that. I missed it out. I'll tell about the dollar sign later.
Okay, sure. Yeah,
If
no.
I remember correctly, this dollar sign is is way to it's sort of uh, if you want to do like step by step, right? Um, so if you want to do and off, so basically what I had written is and of dollar map of equal to 6, say like some element 6, right? And I have 2 comma 3 comma 4 returns false. The same thing, instead without dollar, if I write it will be an error. So what I should do is I should enclose this within brackets. So it's the same as this. So dollar is sort of um, dollar is sort of syntactically it's like a cleaner way to express these kind of logics.
Okay.
That's the high level notion, right? So instead of
Yeah.
using this parenthesis, I'm using this dollar.
Okay. Yeah,
So
got it.
yeah, I'm just removing this parenthesis and this parenthesis, right? And if I go a step further, now instead of map equal to 6, let us see now plus 1 and okay, and now map plus 6. Let's see whether this works. Right. So did you get the difference now, Tyagarajan?
Yeah, yeah.
So basically, if I have like this list of nested parameters, that result should be passed to the outer function. Then that should be passed to the outer function. If I have that list, right, instead of enclosing it within this deep nested parenthesis expression, I can use this dollar sign sort of to have a neater code. So if
Okay.
you compare this one to this one, this sort of without this dollar sign, you can easily like understand. Okay, you have map. You are adding +6 to all these 0 elements, and that result you are again mapping it to equal to 6 and getting a bool. And that list of bools you are adding it using this foldable function. This is the same thing what you will be doing over here, but now you should look at the parenthesis more clearly, and if you miss anything you basically uh, okay, you basically miss out that logic.
Okay. Yeah, got it. Yeah.
Yeah, thanks for raising that question, Tyagarajan. Good. So let's go back then to the question. Just give me a second. Someone is knocking at the door. Sorry for the disturbance. Sorry for the delay. Am I audible? Yeah. Sorry for the disturbance. Right. So good, Tyagarajan. Sort of like thanks to you. Even I solved my query. Like even I didn't fully understand and this dollar sign. Sort of like clear now when you ask. Cool. So good that we learned what is dollar and what is and. Right. And is just foldable ampersand, and this is sort of nested expression like f of g of x, something like this, right? You basically do f dollar g.
Sir, your screen is not visible, like the entire.
Oh, sorry. Right. So this what I wrote. Okay. Are there any questions in this and dollar map? I guess other than this, the logic is pretty simple. You just have to use the function. You just have to find the length of each nested element in the list and see whether it's equal. That's it. Sagar, any questions you have? Okay. So in that case, let's move on to the second question. So here they are asking a square whether it's a square matrix or not. So they want to define a function as square matrix, and it takes a nested list similar to the previous question. It returns a bool, and but the only condition is the number of rows should be equal to the number of the number of elements, number of columns, right? So this is false. So the same test cases as this matrix, the first and second and the third one, and the fourth one is sort of a square matrix because 3 rows and 3 columns, and and the last test case is it has like uh, 4 columns and 3 rows. So this is not a square matrix. So it returns a false. So the logic is sort of pretty similar to what we did for this matrix, right? So I'm just going ahead with the solution because it's the same actually. So here you should also check whether the length is equal, the number of rows is equal to number of columns. So the logic is pretty same as what we did for the is matrix, right? So I'm just checking whether it's a matrix. I'm just reading out the non matrices, and if it's a matrix, should check whether the number of rows equal to number of columns, right? So the number of rows I can get by just having the length on the whole matrix, length of the whole matrix, because that will see the number of independent list, which is the number of rows, and the number of columns will be the same for so number of columns will be same for every row. So if I get the head of that matrix, right? Head of that nested list, which itself is a that list, right? That individual row. And if I get the length of that individual list or row, that will be my number of columns. And now if I check for equality, it should be true. Sorry, it should be same. If it's so, then it's a square matrix. Otherwise, it's a false. Right? I need not check for every row because whether it's equivalent to the number of columns and row, because that check is done by my is matrix. I just need to check number of rows equal to number of columns for the top row alone. That will suffice. Right? So is this logic clear for this square matrix? Okay. Has anyone done something differently other than this? Other than this logic of okay. So um, in that case, let's move on to the third question. Right. So the third question, they want to check whether two matrices are addable if they have the same number of rows and same number of columns. So we should check, take two matrices as inputs and check whether they are addable and return a bool as the output if it's so true or false based on that. So here the first test case is true because it has 2 by 2 because 2 rows and 2 columns, whereas here you are passing a 2 by 2 and a 3 by 3. So this will be false because the number of rows and columns don't match. And in the third case you are passing a 2 by 2 and uh, 3 by 2, right? So 3 rows and 2 columns. So this is also not matching, so you should return a false. So this is what your addable function does, and this logic also is sort of similar to what you have done for the is matrix or the square matrix, right? Because again you should just find the length of rows and columns, right? So I'm just moving ahead to the logic because it's sort of like pretty simple. um, so before that, like, any one of you can share your logic for addable. Hello. Hello, can anyone of you share your logic? Okay, let me just share my logic. So the logic is sort of similar to what we have done for this matrix and this square matrix. So first I check whether it's a matrix or not. I read out the non-matrices. So that's what the first check does. And second, I just get the length of lists in each um, I get the length of um, um, L1 and L2. Right. So I get the length of lists in each matrix M1 and M2, I check whether the number of rows are equal. That's the first condition. Length of L1 and length of L2. That's what this means. And followed by that, I check the whether the number of columns um, present in each element, right?
So
As in the
here,
number of columns
I
between
think,
each matrix, they are the same or different. So that's
okay.
what this zip width does. It operates this applies the equal to operator on both these the number of columns list L1 and L2, and if everything is true, it returns a true. Otherwise, it's a false. I guess that's like a simpler solution because if both are a matrix, um, the number of columns, this length list should be same only, right? Um, as in, like if I just check the first element, head of L1 equal to head of L2, that should suffice, I guess,
Yes.
for checking the number of columns are same, and length of L1 equal to length of L2 for the number of rows. So actually, like this is a simpler solution. So instead of this zip width, right? Basically, instead of going for another recursive call, even this is not necessary. Length list and M2. Um, I can just do length of M1 equal to length of M2. So this will for the row strict, and this is for the column strict. So is this logic clear? So have you done a logic similar to this? Okay, so cool. So the one that I've shared over here within this code snippet is sort of like not so efficient because I'm doing this extra recursive call in zipwidth, and length list I'm just calling again. That's not required. Instead, I can just get the head of the list, head of that nested list, so which returns that individual row. And since I'm just checking whether it's a matrix or not beforehand, I'm sure that the number of columns will be same, right, within that individual matrix. So if I just check for one row, that will suffice. So the logic is pretty simple. And in that case, let's move on to the fourth question. So here we have to define a function add matrices, which takes two matrices. So if you notice the previous questions, the input were of type A, which is sort of like a matrix of any type. But here they are checking for they are want to add matrices. So this they want a specific type, which should be of int, right? Within an int type matrix. So it takes two parameters of type int and returns back an integer matrix. And so that's what your logic should do. So anyone can explain what logic you uh, how did you solve this question? Add matrices. Sagar or Tyagarajan, anyone? Okay, let me share my solution. If you have a different solution, we'll see. So first I check whether it's addable, right? The previous question, right? Addable, whether two matrices are addable or not. I just check whether it's addable. If not, I return an empty list, an empty matrix. So it is not part of the test case, but I just wanted it to be a sort of a complete solution. So I added this if else clause. So now if it's an addable, right? So this is what I'm doing for add matrices, just a key logic, zip width plus m1 and m2. So basically what it does is, if you have a nested list of like say 1 2 3 1 2 3, so basically what I'm doing is and now 2 3 4 2 3 4. So this is uh, m1 and this is m2. So basically what I'm doing is I'm doing the zip width function between m1 and m2. Okay, so this is passed to this outer zip width over here, these two matrices. Now what happens in zip width is each individual element of the list, pair of elements in the list would be passed to the function right over here. This function, whatever I'm passing to this zip it over here, this function f would be uh, is provided, and every individual list element of this list m1 and m2, right? um, m1 of 1 and m2 of m2 of 1, right? So similarly f of m1 of 0, m2 of 0. So in this iterative way, this function whatever I'm passing f function within this to the function which I'm passing to zipwidth, right? This will be applied to each pair of elements in the list that I'm passing m1 and m2, and so basically whatever I'm passing, right? Zipwidth of plus is this f. This is this f function which I'm passing to the outer zip width, and now this will be applied to each individual pair of elements in m1 and m2. So that itself is actually a list. It's a nested list. Now each individual element in that nested list itself is a list. So this will be applied, this f would be applied to this pair of list, and this f would next be applied again to 1 comma 2. So this is one pair and this is the second pair. Okay, and now basically addition is just like same element wise I should just add, right? So since both are list, I am again using this zip width of plus, right? So now what we'll be doing is I'm passing this plus function to this particular zip width, and this plus function would be applied to each individual element. So 1 plus 2, 2 plus 3, and then 3 plus 4, and now you get a resultant list which just is the sum of these two lists, like 3 and then 5, uh, 7, right? So this will be the case of each in application of zipwidth plus on these two lists, and this will repeat for this also. And now these are the two elements, right? And now both of these should be combined and returned back as the answer to the outer zipwidth that we invoked. So did you understand this logic? This sort of like the cleanest logic I could get for adding two matrices. So I should just do an element wise add, and since I know for a fact that if two matrices are addable, the number of rows and columns are equal. That means the number of elements in that nested list and each and the length of each element in that nested list are also equal. So I can invoke this zipwidth in a sort of nested fashion on the outer list as well as on the independent list within uh, which are being passed, right? The pair of lists which are being passed, the pair of rows, right? So, so basically, I pass two matrices. That is for this first occurrence of zip width, and the second occurrence of zip width is basically I operate on the so I basically operate on the pair of rows, row 0 and row 0 in matrix 1 and matrix 2. Similarly, row 1 and row 1 in matrix 1 and 2, right? And that's what this does, is zip width of plus. So any doubts in this add matrices function? Okay. So in that, yeah, okay. Thanks, Tyagarajan. So in that case, let's move on to the fifth question. So given a matrix M1 and a matrix M2, I should check whether it's multipliable or not. So it takes uh, two arguments of any type or matrix type, and I should return it's a bool or not. And if it's a multipliable if it's two matrices are multipliable, it means that the number of columns, oops, the number of columns in M1 equal to number of rows in M2, right? So because if you are doing, say, this is your matrix 1 2 1 2 3 4 1 0 0 1, right? uh, so if you are doing something like 1 2 3 4 5 6 and then 1 0 0 0 So basically these two matrices are multipliable because the number of uh, columns in M1, which is 3 columns, is equivalent to the number of rows in M2, which is 3, right? And the final output matrix that you get would be sort of having the number of rows in M1, right? So you basically get multiply and add, right? So this independent, so this row 1, so if I get like row M1 and row wait, so if I do like M1 R1, M1 R2, and this is M2 R1, M2 R2, M2 R3, and similarly for the columns we can denote M2 C1, M2 C2, M2 C3, and right. So basically you will get the resultant matrix would be 2 cross 3. So it will be like M1 M1 R1 into M2 C1 and add all the elements, right? So basically 1 into 1, 2 into 0, 3 into 0, and add all these three together. That independent single element, you will get single number, that is this element in first row. And similarly uh, M1 R1 into M2 C2, right? So if I just go M1 R1 into M2 C3, so that will be my first row in the resultant matrix. And for the second row, it will be M1 R2 into M2 C1, M1 R2 into M2 C2. So basically, again, I repeat the same for the second row of matrix 1 with each column in matrix 2. So this is what matrix multiplication is. Like, I guess everyone knows, right? I just wanted to explain. So now I should just check whether it's multiplyable or not. That's the fifth question. So the logic is pretty simple. So same way how we check for addable, right? I just check whether both are two matrices in the first place. If so, that's the first condition. And the second condition is this, whether it's multiplyable or not. So for that, what I do is I just take the number of columns in matrix 1, which is nothing but the length of row 1, which is the length of the first element in that nested list, which denotes the number of columns, right, in row 1. So that is this condition, this expression, the column count in M1, and this over here, length of M2 denotes the row count in matrix 2. Right, now number of elements in M2 is nothing but number of rows in that matrix 2, and if both are equal, I return a true, else I just return false. Okay, so is this logic clear for multiplyable? Okay, cool. So in that case, let's move on to the sixth question. So I should define a function multiply matrices that computes the product of input matrices. So this sort of similar to what we did for add matrices, but the only condition is the only difference is in add matrices we sort of, it was pretty easy to have a clean solution, as in we just have to get these two matrices and add pairwise. That's it we have to do. Whereas for multiply matrices you have to repeat the iteration. So if you notice in your C code also, the number of iterations to perform matrix multiplication would be uh, larger when compared to the number of iterations if you want to compare, if you want to add two matrices, right? You will have sort of like three nested loops in multiply matrices, compared to just two nested loops in adding two matrices, right? So I am using the same logic what we have been doing in the C code, but sort of it's the same logic, right? Whatever I'd explained over here, like each row of M1 with each column of M2 matrix. So the same way I'm doing. So let me share my logic. So this is my logic I've done. I'm just increasing it over here. Right. So what I do is I this is my actual function multiply matrices. So first I check whether it's multiplyable or not. That's the check I'm doing. If it's not, I just return an empty string just for even though that test case is not there, just for having a complete solution, I'm having this clause. Else I'm multiply matrices, this auxiliary function I'm calling. I'm passing two matrices M1 and M2, and I'm passing this 0, like sort of like an accumulator. So the 0 is nothing but it denotes which row I am currently in with respect to M1 matrix. So I'm starting from row 0 in the M1 matrix, right? So if it's I'm starting with row 0. So what I do is in this auxiliary function, I check whether the row is less than length of M1. If so, if not, I return an empty list. Okay, that's like the trivial case. Else what I do, I call this function get row M1 M2. I pass the same matrices and I pass the row index and this index over here. So this is nothing but the column index active in M2 matrix. So remember the case where I mentioned, right? Row in M1 multiplied with column multiply plus this add operation with column in M2, and for each row in M1 repeat for all columns in M2. So this is what actually is sort of this nested loop, right? So first I have a function which denotes for this iterating over all rows in M1, and this function is for iterating over columns in M2, and this getRow function would be invoked for each row in M1. Again and again, as well as for each column in M1, right? Sorry, this would be invoked for each column in M2, and this would be for each all the rows in M1, right? This auxiliary function. So the function naming would be sort of like confusing, but that's not an issue. So basically what I do is now I pass this getRow of M1, getRow of M1 M2 row 0. So in this getRow, what I do is I just check whether I've reached the end of the columns or not, and if not, what I do is this is the part where I do this individual multiplication as well as addition, right? So what I do is I use this index operator to get that individual row in the matrix 1. So this row I'm using this index, right? And this index is nothing but um, so the one that I'm passing over here, let me use a lighter color. So this index over here, right? This is the one that I'm using over here, this row index. This is the row index I'm using over here, and so this is getRow of M1 M2 row 0, right? So no, sorry for the confusion. So this row index is the one I'm using over here. I'm correct. So that initially I'm calling the multiply matrices underscore auxiliary function, right? That accumulator that denotes the row index 0, and that is this is what, like this row element. I'm just using it over in the getRow function. So I'm getting the get this specific row in matrix 1, and now to get the column in matrix 2, I don't recurse through I don't recurse through the whole matrix. Instead, I'm using this map function, and I'm using this index operator. So this sort of this higher order function, right? Correct. So I pass this partial function index the element at this specific index, which is represented by this column index. So the column index initially it will be 0. Okay, so this partial function I will be applying to each element within M2. So this matrix M2 will contain, it's sort of nested list, it will contain these all the rows, and now within each row I am getting only the elements at that particular index or in that particular column. So basically it will give out a list which contains just column 0 in M2, right? So column 0 or column 1 in M2. So that's what my L1 and L2 are now. And now what I do is, finally what I should do, given this row in M1 and the column in M2, the column and row in M1 and M2, I should sort of multiply the elements pairwise and then add all the results together, and that will be that individual element in that result matrix. So for that I'm using this get element function. I'm passing these two lists, which is the row in M1 and the column in M2. And if you notice the get element function, what it does is it first applies zip width through this L1 and L2, right? And this zip width is nothing but it does a pairwise multiplication between L1 and L2. And once that is over, what I do is I should add the resultant output, right, to get that single element. So for that I just fold the list, and with 0 as the accumulator, I just fold the list and I get one single value. So that is the so that will be part of my that will be the output of multiplying that row in M1 and the column in M2 and adding that and folding that list, right? So that will be my output of get element. So starting from row 0 and column 0, I invoke get element on that row 0 and column 0 in M1 and M2 correspondingly. Now I should repeat this, keeping my row in M1 the same, that is row 0 in M1 same, but the column in M2 should be incremented by 1. I should repeat the same process, right? And basically, if you notice the output of my resultant matrix over here, right? The first element, as in the first row of the resultant matrix, is row 1 into column row 1 of M1 into column 1 of M2. The second element in row 1 of the resultant matrix is row 1 of M1 into column 2 of M2. So my column should change in M2, but the row in M1 should be the same. That will be my second element in the same row in the resultant matrix. So that's why what I'm doing is I'm having this cons operator. So I'm just appending the rest of the elements as part of the same list. So I'm just appending all these things over here, right? So it will, this get element will again this get row will be invoked for every column in M2, keeping M1 row same. So if you notice, this row value would be the same across all invocations of the get row, the recursive invocations. And so once I just keep on doing this, I will reach the condition where column is equal to the length of the column. The column index has reached the end of the matrix, end of the columns, and then it will just return an empty list. So basically, by the time what I would have been done is each individual pair of those row and column multiplications I would have finished, and I would get a list something like 1, 0, 1, something like that, which denotes that particular row index in the result matrix, in the product matrix, right? In the product matrix. So this is what get row does. So get row is nothing but that whole row in that product matrix. It will compute by recursively. It will compute recursively by multiplying that row in M1 and every column in M2 recursively. And once that is done, it will construct that row list and return back. And now the get row returns back the list, right? So in your product matrix, like say if your product matrix is 2, 3, the get row would return back row 1 in the product matrix. And now to get row 2, you should again call this multiply matrices underscore auxiliary function. But here if you notice, I'm increasing the row index by 1, incrementing it by 1. So now what it does is so it just repeats the same. So it will invoke a get row of m1 m2 with this updated row index and starting from column index 0, and once it reaches the end of the rows in matrix 1, which is this condition over here, it will return an empty list, right? So this is the logic for multiply matrices. So it's sort of the naive solution in my opinion, because there might be better solutions. I didn't optimize for tail recursion and all those stuff, but this sort of the same thing that we do in normal matrix multiplication. But there might be like other variants of matrix multiplication which are sort of faster compared to this naive version, or like fine tuned to the FP style of programming. But this like sort of the one that like we get it in the top of our head, like whenever someone asks us to multiply two matrices. So is this solution clear? This sort of like I've used three helper functions, and the way I used it is like each denotes one nested iteration. So is this clear? Okay. So in that case, this is the end of the week 5 assignments, the programming assignments. So let's. So if you don't have any other queries, then let's wrap up the session, and let's meet next week, same time, Friday 6 o'clock, the same meeting link.
So just before that, I have posted my solution in the chat box. If you can just have a look.
Or did you post it? Oh, okay. So this is your whole logic for matrix multiplication, is it?
Yeah, so there are a couple of auxiliary functions
Okay,
mentioned in that.
dot
I have not.
product and transpose.
Yeah.
Right.
So dot product, I think, is essentially same as your get element. Uh,
Okay. Right. So
but
so
but this
basically,
is a partial function here. So there is only uh, one list passed x.
so transpose does this. Okay, transpose basically you do the transpose. Okay, you get the column.
Yeah, so that column I transpose the matrix so that I can then directly look at. Uh, I can directly get the lists out of that
Right. Right.
instead of going through all the columns. I first transpose so
Right.
that then
Right.
the first
Okay.
first
Okay.
row in first matrix and that in the transpose matrix, the first row is essentially the first column.
I get it. So basically, you iterate over the rows. That is the outer map in matrix one, and
Yes.
inner map is the one where you this dot product does get element, um, and yeah, right. So get element it multiplies the
The
right
first see, so the outer map. Uh, the
fastest
first
right.
mat one, the first row of mat one is passed to the outer map first, and then the first row of mat one is multiplied with first column of mat 2, second column of mat 2, third column of
Right.
mat
Right.
2. That's the inner part.
Is right. So this will be for row of mat 1,
Yeah,
and this will be column of
column of
mat 2,
mat 2.
and this will be repeated for every column. and this will be repeated for every row.
Every row. Yes.
Right. Nice. This nice and cleaner actually. Nice, Tyagaraja. Okay. So, are there any queries apart from this?
So in these assignments, I mean, are the questions posted? I mean, the assignment questions, are we supposed to use the logic? I mean, the topics that were covered in that particular week, I mean, are they somehow related, or these are kind of independent? Because I
I'm
think the solution, of course, does not check whether we have used those topics,
right,
but
right. It doesn't
so
check. I'm not sure of that. I'll ask the TA and
no, because in this week, I mean, there were some topics like abstract data types, like you
right, right,
can, instead of uh, uh, like you can use type synonyms, you can maybe define matrix A as a type instead of list of lists, and so I mean those things, I mean,
yeah,
where
we can. Even I thought of, but in the question itself, they had mentioned
yes,
nested
yes,
list of ints, right?
yeah,
So,
the function definition already mentioned that. Yeah.
right. So it didn't make much sense to me if we are defining abstract types. It doesn't matter, right? So
Yeah.
functional. But I'll anyway uh, have a word with the TA and get back to you.
Yeah, I mean, usually we are more inclined towards a more, uh, I mean, using the simpler functions,
Right,
and I
right.
mean, so we are
Yeah,
not essentially making use of the high, I mean, the advanced level topics that are being covered.
right, right. I'll discuss with him and I'll inform you.
Okay. Yeah, sure. Thank you.
Okay. So if there are no other queries, then we can wrap up the session. Thank you all for attending the session and making it interactive. For asking questions and learning together. Right? So thank you very much. Let's meet next week Friday. Okay. Thanks Tyagarajan. Thanks Saga. See you. Have a happy weekend.
Yeah, thank you, sir.